Dear student of B.Tech first year, I am Dr. Ravind Parsai, Associate Professor of Mathematics in Engineering Science Humanity Department at Chamini Devi Group of Institution, Indore. I wish to discuss today through lecture 2, solution of second order linear differential equations with variable coefficient by special method 2 with examples, and special method 3 also have been discussed through this lecture number 2. So first of all, we understand what we mean by method number 2. So that is normal form. We call also the method 2 as normal form or complete solution by removal of first order derivative from the given equation of second order with variable coefficient. If an integral included in the complementary function cannot be determined by inspection method, it is sometimes useful to reduce the given equation to normal form as follows, in which the term containing the first derivative is missing. So first of all, we put the given equation into standard pattern, that's d2v by dx square, that is d2y by dx square plus p dy by dx plus q of y equal to r, in which the coefficient of d2y by dx square is unity. And now we come to step number 2. To remove the first order derivative, we choose u equal to e raised to integral minus of 1 by 2 of p dx. Then we come to the third step, as we come to in the previous case also. This is to be same. So now we choose the complete solution in the form as y equal to u into v. Then the given equation is reduced to the normal form as d2v by dx square plus I of v equal to s. That is, now we will find the value of v by using this formula, where I का फॉर्मूला है q माइनस 1 बाई 4 पी स्क्र माइनस 1 बाई 2 डी पी बाई डी एक्स, and the formula of s is r by u. Now the above equation can be solved by usual method, as we get v. We will solve this equation and then we substituting the complete solution as y equal to u into v. Now the above method is well explained by the following example. Let me concentrate example number 1. d2y by dx square plus y into cot x plus 2 into dy by dx plus y tan x equal to sec x. If you have observed second order differential equation with variable coefficient, first of all you reduce into our standard forms. So for this, the given equation can be written as d2y by dx square plus 2 tan x dy by dx. So that is terms having d2y by dx square multiple coefficient is 1, and the terms having dy by dx is equal to 2 into tan x, and while the terms having y is 1 plus 2 tan square x y, and the rest terms you shift it on the right hand side, sec x into tan x. And now on comparing with this equation with our standard forms, d2y by dx square plus p dy by dx plus q of y equal to r, and then by comparing by this, v equal to 2 tan x, q equal to 1 plus 2 tan square x, r equal to sec x tan x. Now to remove the first derivative, we choose u is equal to, what will be the formula? U is e raised to minus of integral of 1 by 2 of p का मतलब है 2 tan x dx. Now just by integrating this function, because we know that the 2 से 2 cancel जाएगा, minus sin x रहेगा, but you know that integration of tan x is minus log of cos x, तो minus minus आपका एक कट गया और e की पावर जो है वही बेस इसमें है, तो इसलिए log हट जाएगा, एलिमिनेट हो जाएगा, तो आपका जो सिंपली आंसर आएगा cos x. Now we choose the complete integral or complete solution of given equation by y equal to u into v. Then the given equation is reduced to the normal form as d2v by dx square plus iv equal to s, or we can say that the formula for finding the another complementary function is v by this way, where I is calculated as by the formula as q minus 1 by 4 of p square minus 1 by 2 of dp by dx. and just substituting, this gives to you 1 plus 2 10 square x minus 1 by 4 10 square x minus 1 by 2 sec square x. So after solving this is to be 0, and then you find r equal to s equal to r by u. The value is sec square x into 10x. Therefore on putting this value, so this equation is reduced to this form. What is this? It is second order differential integral equation, because it is in variable separable form. Just by integrating you will get the answer. As first time when you integrate, you will get left side dv by dx. On the right hand side you will get the integration is 1 by 2 of sec square x plus c1, and again you integrate, you will get v equal to 1 by 2 10x plus c1 of x plus c2. Thus the complete solution is obtained by putting as y equal to u into v, cos u की value है cos x and v की value है this. Let me concentrate one more example on the same method. So this is your question of second order differential equation with variable coefficient. Just plus you reduce into this pattern here, or comparing into this pattern, because in this question already the coefficient of d2y by dx square is 1, so there is no change is required in this given equation. Just compare with our standard forms, then finding p equal to minus 2 by x and q equal to 1 plus 2 upon x square and r equal to x e raised to x. So now for removing first order derivative, first we find u equal to e raised to minus of integral 1 by 2 of p dx, so equal to minus of this substitution 2 से 2 कैंसिल हो जाएगा. Simply this gives to 1 by x log x का इंटीग्रेशन होता है log of x, so simply this gives to u of u x here, x की पावर माइनस 1 तो 1 by x हो जाएगा. Simply this आपकी वैल्यू मिलेगी. So now therefore where you obtain complete solution, you will assume is equal to y equal to u into v is equal to 2. So then the given equation reduced to normal form, that is we find the value of v by this formula here, where I is calculated by this formula q minus 1 by 2 1 by 4 of p square x. So the value is minus 1 by 2 of dp by dx. So p is equal to, you can put here, and r equal to, substituting this gives to you after simplifications some terms are cancelled, simply you get 1, and r by u gives to you the value of this e raised to x. Hence the equation number 3 becomes, on putting this value in the equation you will get d2v by dx square plus v equal to e raised to x. That is by taking converting, this is second order differential equation with constant coefficient, we reduce into operator form d square plus 1 over v equal to e raised to x. Then first we find the auxiliary equation. We write here auxiliary equation m square plus 1 equal to 0, that is m equal to roots are plus minus I, that is imaginary. Then how can you find CF? CF is e raised to alpha x, real part is 0, तो 1 हो जाएगा c1 cos of x plus c2 sin of x. And now you find the pi as e raised to x upon d square plus 1, that is in place of d you will put 1, because e की पावर में x का कोएफिशिएंट 1 है, तो हो जाएगा e raised to 1 plus 1 is 2. Therefore thus we can say that the complete general solution of this equation is v equal to cf plus pi c1 cos x plus c2 sin x e raised to x upon 2. Thus the complete solution of the given problem is to be obtained as by putting y equal to u into v equal to x inside the bracket c1 cos x plus c2 sin x plus e raised to x upon 2. Now we concentrate method number 3. So method number 3 is based on method of change of independent variables. So whatever the differential equation is in second order differential equation with variable coefficient, you just change the value of independent variable into some parameters, or transforming the equation by changing of independent variable. So sometimes by change of independent variable the differential equation may become easily integrable. So in this case first step is to reduce, is identical with our previous method. We reduce into given equation number 2 or this is standard forms by making the coefficient of d2 by dx square equal to 1. And then we come to step number 2 is Now we choose a following relation between the new independent variables z and the old independent variable x as dz by dx whole square equal to plus of q. Note that carefully that we omit the negative sign of q. Now we solve the above equation, so we get dz by dx equal to under root of q. Just on integrating both the side, you will get integral of this z is left side का इंटीग्रेशन होगा z, right hand side का whatever with the value of q, you integrate accordingly. So we omit the constant of integration since we are interested in finding just a relation between z and x. Now we come to step number 3. With the help of the above relation 2, we transform the equation 1 as d2y by dx z square plus p1 of dy by dz plus q1 of y equal to r1, where p1, q1 and r1 is defined by this formula. p1 is calculated by d2z by dx square plus p dz by dx divided by dz by dx whole square, and the q1 is q upon dz by dx whole square and r1 is r upon dz by dx whole square. After solving equation number 3 by usual method, the variable z is replaced by the relation 2, and now the above method is well explained by the examples in the next lecture. Thanks.